UI Toolkit is still an incredibly divisive feature in Unity. If you're someone trying to figure out which one to use, or you're using UGUI and have just been waiting for the right time or reasons to make the switch to UITK, then this video is for you. Because I believe that the initial understanding it takes to get started with UITK is more than a worthwhile investment due to the many gains and potential alleviation it provides when building out user interfaces in the long run. I've been using UI Toolkit in my projects for a few years now, and for me, there's no going back. Hi there, I'm Matt, and welcome to Game Dev Guide. In this video, we're going to look at 7 ways UI Toolkit has improved my experience of building out UI compared to UGUI, and why you should consider using it in your projects too. We'll explore some of its unique features and the ways in which it deals with some pain points of implementing a user interface in general, but we'll also look at how easily it handles some of the things that are just inherently difficult or complex to do when building an interface with UGUI. By the end of this video, you'll have a more comprehensive understanding of the benefits a UI Toolkit workflow can give you, and have all the information you need to assess if you're going to stick it out the old way or join me in the land of UITK. Which brings me to our first UITK feature, data bindings. In UGUI, there's a lot of boilerplate code involved to keep all of your UI in sync with your data as it changes. Your UI components need scripts on them to link to the data you care about, and for each piece of UI you add or change, you need to write a bunch of code to keep things in sync. So, as your project and data grows, there's more and more work involved in keeping all of your UI up to date. Complex UI systems get messy as the project grows, and the code required to maintain it scales too. In UI Toolkit, you can keep most of your UI elements in sync with your data in just a couple of lines, thanks to data bindings. Let me show you an example of how it works. In the editor or your XML file, you simply set up the data paths, sources, and properties you want to bind to. And then in your script, you assign the data you want to track to the data source property of the UI element, and everything is handled for you automatically. Anytime your data changes in your game, your UI updates to reflect that change. You can also control whether the change is one-way or two-way, meaning that input fields can instantly set their value on the data they're bound to as well. There's frankly a lot of depth built into this seemingly simple binding system, which we'll explore a little later in the video, but with its default configurations, you can get a simple UI up and running within minutes with little to no code needed. And when you add new data to your sources and need an additional element in your UI to represent that data, you can simply configure them in the editor here and they'll automatically work. You spend a lot less time faffing around with tracking data and more time being able to focus on designing your UI itself. Speaking of which, UI Toolkit gives you a lot more variety in how your UI can look, thanks to the second point on our list here, UI themes. Now this one is seemingly small on the surface, but packs a lot of punch when you think about it, as not only would it be quite difficult to pull off in UGUI, but it's an incredibly versatile feature that you can take advantage of in many different scenarios. In this example, I have 3 different biomes, and as you can see when I switch between my scenes here, my UI changes and matches the environment we're moving to. And this is trivial thanks to USS themes and variables. Variables allow you to share values across different USS selectors. They can live in the USS file that they're being used in directly, or in a top-level USS theme. A theme is kind of a global USS script that every UXML document can see. So we can define a few key variables in our USS theme here, such as base colors and accent colors, and then we can reference these variables in our various style sheets for our UI elements. From here, we can switch up the theme at runtime to essentially override these values depending on which style we want. And so in this example, when the player switches up scenes, we just swap out the theme we're using, and hey, look at that, an entirely different color palette. Now I'm using it to just swap colors here basically, but as I'm sure you can imagine, this is an incredibly versatile feature that your UIs can take advantage of. Perhaps you have different themes for different devices your game is running on, or you change the entire layout of your UI depending on the input device. There's a lot of cool things you could potentially do with this, but even a palette swap is something that I can't even begin to imagine trying to do with UGUI very easily. You'd probably need to rely on some complex boilerplate architecture with scriptable objects that you swap out, and you'd have to custom build versions of your UI components to handle it. At which point you're basically just doing the USS thing yourself, but in a much more convoluted way. So having all of these variables in UITK and swapping them out with a different theme file is definitely the way to go. And on the topic of files, UITK files are mergeable. As you might be aware, one of the biggest headaches of using Unity in a team is when multiple people are trying to make changes to a scene or prefab at the same time. And so as UGUI is part of both of those structures, if I'm trying to make a change to a certain part of the UI, and you need to make a change to maybe a subset of that same UI, we either run into a merge conflict because our source control is misconfigured, or the file is locked by me while I work on it, and you just have to wait for me to check it back in, but oops, I've gone to lunch. So you're now killing time watching YouTube videos while you wait. This is one of those sneaky workflow bottlenecks that adds up over the course of a large project and greatly reduces productivity. And while it might be less of a concern if you're not working with other people, for the rest of us, avoiding merge conflicts and simplifying the source control process is greatly desirable. I have regularly been working on UXML and USS files along other team members, and because they're text, that source control can just handle them without an issue. And if you're looking for a good, game-friendly source control solution, allow me to introduce you to this video's sponsor, Diversion. Diversion is a cloud-based version control solution built from the ground up to solve source control problems for game developers. It's designed for projects of any size and handles the scalable nature of game projects with ease. With Diversion, you can commit thousands of files in seconds and handle hundreds of commits without slowing users down. You can manage large assets, prevent conflicts, and sync effortlessly, all without the overhead of legacy tools. As it's designed for developers, Diversion's fast, branching, conflict-free, and intuitive UI make it friendly to all kinds of workflows, whether you're a designer, programmer, or artist. And with the free Diversion plugin for Unity, you can stay focused on your project at all times as your team can share, track, and roll back assets or code changes from within the Unity editor itself. With special markup of files and a dedicated merge warning notification, you can get ahead of conflicts before they happen. Diversion is simple to set up and can be integrated into your project within minutes. Pricing scales with your project, so you don't end up paying for things you don't need. Alongside the generous free tier, there's specific pricing tiers for both indie and educational users. And there's also a dedicated Discord community available for you if you need help with anything. So, if you'd like to try out Diversion for yourself, follow the link in the description down below or scan the QR code on screen now. And you can save 10% on any of the tiers by using my code 10GameDev12 and know that you're supporting the channel at the same time. Thanks so much to Diversion for sponsoring this video, and thanks to you for using my links when I have them. Now, let's get back to the video and the next reason why UI Toolkit is worth considering. Custom bindings. Custom bindings are kind of a hidden gem of the UI Toolkit workflow, and frankly, I'm surprised there isn't more coverage on them because they're insanely powerful and essentially unlock a variety of different behaviors on your UI elements, as they allow you to share and manipulate behaviors across certain types of data formats. The best way to think of them is that they're a way to override the binding logic of your UI element properties and control them directly. Let's say, for whatever reason, I want to show a random string of numbers in my UI here. I have 3 different UI elements, all with different sources. I want to change this string here to show a random number. I want this button label to show a random number, and I also want this input text box to show a random number too. One way to do this would be to grab each of the elements in a UI script on our object, query these different elements, and then set the values on them. But if for whatever reason we wanted our random number generator to work on other elements or other documents, we'd have to repeat this behavior for each new element. With UITK though, we can write a custom binding script, and then in UI Builder, we can bind that script to the various properties of our UXML instead. Let me show you what that looks like. So here's my custom binding script. It's a partial class and extends from the custom binding type. We include the UXML object attribute at the top here and flag any controls we want to expose with the UXML attribute. In the constructor, we'll tell the script when to update. In this instance, I want my numbers to keep changing, so we'll set the update to trigger every update. Then in our update method, we'll generate our random number. We'll do some error handling to make sure that the property type we're trying to bind is valid. So for this instance, it would be anything that accepts a string value, and then return that result if it is valid, or throw a binding error if not. Then in the binding window of our UXML, we should now see this custom binding appear in the dropdown here. We can simply select our binding type, click apply, and just like that, we have our random number generator working across a variety of different types of elements in just a single click. Now this is a pretty unlikely example of what you might want to do with this, but hopefully you can see that it's a great way to apply the same behavior to different mismatched UI components. Similarly, while it's not quite a custom binding itself, we can extend bindings even further with converter groups and have certain values in our data control other style elements. I have this Boolean value to show that my character is ready to level up. I also have this UI element that I'd like to show when the Boolean is true. By default, we can't bind this element's visibility to a bool, but with this converter group script, we can add a custom converter to read a Boolean and have that determine a display style for us to use. In the binding window, when we try to bind our Boolean, we just have to add our converter group in here, and we can successfully attach the binding. Now, whenever I change the level up flag in my data, the UI element updates its display to match. We get a lot of complex behavior essentially for free. Speaking of which, my next point is probably my most treasured feature of UI Toolkit, and that's how animation is included. We all know that one of the biggest pain points of UI is animating it. You'll often need to rely on some kind of tweening library and write a ton of boilerplate code to get UI objects moving around, or you're having to hand animate various components in the animator. Oof. In UITK, it's something you really don't have to think about because it's just part of the process of setting up your selectors and often just takes a couple of clicks. In code, all you have to do is add or remove the selector you want and it just works. You can, of course, chain together sequences of multiple selectors to get more complex behaviors, but out of the box, a lot of the default behaviors are more than good enough for simple transitions between panels or introductory juice when an element first appears on screen. One of my go-to examples for why I love this so much is my leaderboard in Cabs of Chaos. Each element here is identical and bound to a character in the game. When the leaderboard changes and the character order needs to be updated, I simply set a selector on each element corresponding to their current position. The selector determines where that actual element should be positioned on screen, so the moment it's added, it transitions from its current screen location to the location designated in the selector. With just a first, second, third, and fourth selector, I can have all of these elements dynamically move and respond to the game state with no extra work. It's made something that's normally quite annoying to implement incredibly simple. And as someone who's had to implement and maintain a lot of UI behaviors in UGUI over the years, I just absolutely love this because I don't have to spend a ton of time coding UI transitions. Now, if you're a code purist and the reason you love UGUI so much is that you can just build and write all of your UI in code, well, I've got good news for you. You can code everything too. Writing UI element code is no different. You don't have to touch the UI builder if you don't want to. In fact, there's basically 3 ways to implement a UITK UI. Obviously, you have the what you see is what you get approach with the UI builder window. I prefer this personally, as once you get familiar with it, it's incredibly fast and effective. But if you're coming from a web dev background, you can also just write all the USS and UXML code yourself. This can be pretty useful if you're used to that approach, and it's arguably a faster way to work than the editor if you want more flexibility and control. Alternatively, you can also just write good old C# to build out all of your UI. I'll often just still build my custom editors and tools this way because I might want to write more complex behaviors or interconnect some of their logic. As I've explored on the channel in the past, I've built entire node-based editors using the code approach. What's even cooler is you can write your code and then still take advantage of the debugger to make tweaks and fine-tune your results in real time. So you really can get the best of both worlds. Not only that, but you can also write a number of different custom components with a variety of different behaviors for your UIs. Whether that's a radial progress bar, a line renderer, or a special text element that you want to use, you can write these in code and then they can become elements you can use and manipulate in all 3 ways. You get a lot of flexibility and compatibility depending on how you like to work or what purpose your interface needs to solve. And so it's great for programmers, but it's also way more accessible for other team members because you don't need to be a programmer to make UI. With UI built in UGUI, there's often a lot of time and resources spent keeping it up to date as your game rapidly evolves. Even if you have a UI designer on your team, they'll frequently need help from a programmer to get it working or updated. I know firsthand that there's a lot of back and forth involved there. In the projects I've worked on, UIToolkit has allowed for much more flexibility and scalability with our UI throughout development, just fundamentally due to how it functions. As I'm sure you can see from earlier in the video, it scales incredibly well with your game and often requires little to no code to keep up to date with changes. This means that artists and designers can noodle away at it as much as they like and continue to refine it. Similarly, as it shares a lot of similarities with a web-based UI solution, aka an industry standard one, it's extremely accessible for folks used to working in those environments. So if you're looking for UI artists, you can reach a lot more candidates with a UITK workflow than a UGUI-based one. So those are 7 reasons why I think you should consider using UIToolkit for your projects. As I'm sure you can see, there are many strengths that it has over the old system, and with the addition of world space UI and custom shader support in the most recent Unity version, it's almost entirely up to feature parity with UGUI at this point. I definitely think if you've been on the fence about using it, it's time to reconsider. If you've enjoyed the video, be sure to hit the like button, and if you're new to the channel, please consider subscribing so that you'll be notified when a new video goes live. If you'd like to learn more about UIToolkit, I've actually covered it a bunch already here on the channel, including a getting started video to show you the ropes and build out some basic UI, so be sure to check that video out if you haven't already. As always, thank you very much for watching, and I'll see you again next time.